Hi and welcome to my PlayHouse, and today we're back in the data center as many of my videos are. And yesterday I was doing a video, I was unboxing a APC oops that has been sitting in the box for 8 years and the batteries was dead. It was a disaster, but while unpacking and unboxing the box, I found this cable that was for the oops to communicate with a computer, so you could like plug this into a computer and plug this into the oops. And I was a little bit disappointed because I was really hoping that this plug in the oops would mean that it would be able to do a network connection, and it was not. So later yesterday I went online to find out what this cable was really used for, because the manual was kind of thin. And I stumbled across something really interesting. Somebody had connected this to a IBM server. And do I have IBM servers? I guess I do. And they found something interesting in the Intel, or what is it, Intel quad-core processor line 5400 series, which is, it's kind of the second line of Intel processors with quad cores. The first line was the 5300 series, which they were not really that popular, and they were giving out a lot of heat and not performing very well. And I found an article about this, and it turns out that those processors they were probably okay, but Intel didn't make a lot of money on them because too many of them failed in production. So like there were these quad cores, and all 4 cores had to work for the processor to be accepted as a good one, and there was too many processors that failed. So they didn't sell a lot, and the processors became so expensive that they didn't do very well. So when Intel was planning their next line of processors, they made a really interesting decision. They put in extra processors because they found out that this is making some noise. They found out that the cost was not really the silicium inside of the processor, it was all the hard work behind it, testing and managing and getting the processor through the production line and having it come out as a good one. So what they did was they put in extra processors, and the point was that at the end of production you could like test the different processors and just mark the ones that was good, and then you would have like a quad core. Take the good processors and disable the bad ones, and you would have a quad core processor. And I don't know how or when in the production line this was done, but they made every processor with 8 cores. So inside an Intel X54 something, there is 8 cores, and then they are just disabled along the way. And I have to go see what the dog is barking about. Just a second. Well, I was just looking around to find a processor, and I haven't got the right one. They're all mounted in their servers. But yeah, the processor, this is a rather larger one, but you know, it contains of a lot of legs, and it's really only possible to test the processor when it's mounted in its case and so on. And at that point it's very difficult to physically disable the cores inside of the processor. So what Intel did, which is really weird, but it's fairly often done, they would disable the cores that was not used through some kind of software. Yeah, well now, most of you probably know that IBM has split out their X series and sold that off to Lenovo. So we are looking forward to seeing what kind of products that comes out of that. it was very exciting when it happened to the computers and laptops, and we haven't been cheated there. But IBM sold out their X series to Lenovo, and somebody found out that there was like a contract with Intel that was never signed. They sold everything to Lenovo, but they forgot to have Lenovo sign the contract for non-disclosure on the CPU architecture of their old X54 processors. And it seems that it's the server producers that in their BIOS software have to disable the extra cores on each of the CPUs. I'm gonna put this away, it's not the real CPU anyway. And no one has ever really broken into the Xeon line of processors, and it's not really able, no one has ever been able to overclock them or anything like that, and it's probably because that contract is very harsh, like death and destruction. But somebody found out how, and they used this cable, because on the back of an IBM server, I only know this about IBM because IBM, they make mainframes, and on mainframes it's a normal thing to put in a lot of processors and disable them from software, and the users can pay a lot of cash and get access to the more processing power. So at some point, even though IBM made this disclosure contract with Intel, they thought, well, at some point Intel is gonna come and say, okay, you can use the extra processor, the one that works. And IBM thought, I'm speculating here, they thought, when that time comes, we want to make that extra money. So they actually made a software. It's possible to open up the extra cores from the what is it called, RSA adapter in the IBM server. So the management adapter can be programmed to do this, and of course this was done by some Russians, and I stumbled upon their website. So let's go see what the Russians did. I'll start by putting in the cable. Okay, just going in on the backside of my data center here. Just gonna take one of the servers here. Well, this is the management adapter. We'll detach this one, and we'll plug in this cable right here. And the other part of the cable, which is the USB cable, can go into 4 USB ports, but it actually seems that it's number 1 that is able to talk with the RSA adapter that is sitting right in here. Can you see that blinking? But yeah, if you don't know the IBM X3650, you really should. It's a lovely server. It's one of my favorites, or it actually is my favorite. So we plugged in the cable, and I'm just gonna power it on. There we are. I really have to give some thanks to this Russian dude that has figured this out and found the paperwork that said that this was possible, and digged into it. And I'm not able to talk Russian, but his name is rusiske. Yeah, that's a cool name in Russian, I guess. Our newfound Russian friend also has a web page which in Russian explains this. So to go there and understand it, you probably have to translate this into English or something. And there's some scripts on that homepage that has to be copied, and you're gonna run those in the RSA adapter. And to get access to the RSA adapter, well, according to the Russian report, this should be a picture of the X54 series inside the cores. The frequency can vary on these, but there is like 1, 2, 3, 4, 5, 6, 7, 8 things in here, and some way they can select which ones to use. And apparently some Belgian student in a university took this picture and was wondering why there was 8 cores, and he started asking questions, and suddenly he was expelled because of drinking, and he didn't drink. That same year, all the teachers, computer science teachers of that university, was in the Polish city of Słuchacz for a seminar on DB2 database optimization. Apparently that year the world competition, or the European world competition in pole dancing, was in that city at that time. So the Russian thinks someone was bribed, and it was just like a shut the fuck up trip. But well, to do this on your IBM server, you have to start by logging into the remote supervisor adapter to... I'll just log in first. Nope. Continue. The first thing you have to do is restore default. I've already done that, and that was why the password was the default password. And then you have to go into, oh yeah, here. The telnet protocol has to be set to the tele connection count 2. And there is like 3 options. You can disable it, and 1 and 2, but set it to 2. And the firmware in here has to be rather old. I think IBM patched it at some point so that this is not possible anymore. But I'm so lucky that my firmware is from 2009 and 2010, and that's kind of okay. For the rest of it, we need to use telnet. And to enter, just need telnet. And if you're working on a Windows 7 machine like I am, you will have to go into add programs and features and programs something, and enable telnet, because it's disabled in Windows 7. And we're gonna connect to the RSA adapter on the server. Connecting, and the username is the default user ID, and the default on IBM server is password with an O. And big letters. So we have connected, and we can see the different types of things we can do. The big problems is that we don't get anything by enabling processes that are hidden. So we have to go back to the script from the Russian programmer, hacker, whatever you call him. Not sure you can hear that, but let's put down to the microphone down to the speakers. Yeah, that's the dude. On our good Russian hacker's homepage, our Russian hacker who is... I'm not able to say that in any way. He has left this code that he has made in November sometimes, and I'm not a programmer, and I'll just be playing script kiddie, and this should start the programming, and the 2 first lines should blank the screen on the RSA adapter. So I'll go in and do that. I am really lazy, so we're just gonna copy the first 2 lines here, copy paste, and we're gonna put them in here, and the screen goes black, and my camera is not very happy about focusing on the black screen. Focus on my fingers. And if your screen doesn't go black, be sure to go in on our Russian let's just find his name again.
Это первоапрельской.
Homepage, and I've gone through the trouble of making a Google Translate of it, and I'm not able to link directly to this in the film, but it will be in the description of the video. How to get in there and solve out this problem. It's very important that the screen goes black. Otherwise you could be ruining something, I don't know. It's just putting in bad programming and something that is not really taking it. So, well, we're gonna go back, and I'm just gonna, we'll just explain what this is. Some programmers has had a lot of fun, and there's like, this is the different cores inside the CPU. The program opens up some kind of communication from the RSA adapter in through the BIOS and down to the CPU. So to do this, the server must, it cannot be booted. It should not be doing anything. It's a good idea to boot the server and place it in the BIOS or something, somewhere where it's not really doing anything. So, but these are the different processors, and if you look very carefully, this is number 0 and this is number 1, and it's a 1 upside down, and this is number 2 upside down, and so forth, and up to number 7, because we started at, oh, you can see that, up to number 7. It's and randomly Intel and probably IBM has they have disabled some random ones and tested the ones they got, and if that worked, they would just ship the processor and that would be good. But there are 8 cores in there, and more than 4 will normally be good. The same time they did this, they also got a new machine, or probably a lot of new machines for doing processors. So very likely all 8 processors are good. But I'll copy this, except the first 2 lines. The first 2 lines are important to go into the programming mode. If that doesn't work, you have to go to the homepage and see there's different ways to solve that. Here's some suggestions on going back into earlier firmware versions and stuff like that. Just gonna copy this and minimize this and go back to our, now we're out of, and we're gonna paste that in here. And to paste that, we're just gonna paste it, and it comes on with a lot of code. And go. And it says that this is not a supported commando. We believe you. And now it's just important to boot the server. RSA2 adapter in the IBM server. It doesn't understand this code. Now I should have enabled all 8 cores in my Intel Xeon X5450 processor. I might have a bad one. It's like back in the days we had all these pixel errors on our screens, but nowadays there's none. And when IBM started this, they had a lot of errors on their processors, and at the end of it there were no errors. And I luckily have some rather new processors, like the late ones that they did. So I haven't found a core yet that didn't work. Here I've booted the server in VMware, and it's this one. It's number 2 of my ESXi servers. And VMware is one of the programs that has absolutely no problems with this. It still sees 2 CPUs. It now sees 8 cores and a total of 16 threads. The X5450 does not have hyperthreading, but now it has the double amount of cores. Right now, I haven't started any virtual servers on this machine, but now it has 16 times 3 gigahertz available for it. Yeah, and that's kind of it. If you want to use this for Windows 2003, it's apparently not going to work. Windows 2003 is too old. Windows 7 should work. Windows 2008, 2012 should work okay. Linux, Unix, I have no. Yeah, so if you're ready to get the maximum amount of power out of your old server. That's how you enable the cores inside of the CPUs that Intel and IBM has laid dormant for getting a larger profit on their servers and having better file tolerances. All the servers I have are of later models. They've all worked out pretty well for me. So I'm now able to double the amount of work that these processors can do, and the only thing that I have to worry about is if they produce more heat. And so far it's minimal. Normally the CPUs are not used that much for them to peak a little bit and go up and down. That's okay. So hope you enjoyed this video, and if you want to see more videos that on other subjects than this, be sure to check out the link in the descriptions to the Russian programmer so you don't fuck up your servers. And while you're looking at all this boring programming of the RSA adapter, be sure to give my video a thumbs up.